Welcome to the second chapter of our series on quantum mechanics. Today, fundamental forces. You probably know things are made of atoms, and these are made of particles. But do you know how these interact with each other? Welcome to a series on forces, the Standard Model, and quantum mechanics. Today, the fundamental interactions. Our first force is gravity. You all know Einstein. And from high school you probably remember this equation from Newton. Gravity is the course of mutual attraction between objects with mass. The greater the mass, the greater the attraction. Our best tool to describe its effects at the moment is general relativity. Gravity is by far the weakest of all four fundamental forces. For instance, see there are almost 20 orders of magnitude between the gravitational constant and coulombs, which is the one we use for our next guest, electromagnetism. Electromagnetism is, along gravity, the other force we can perceive in our daily life. In fact, that salt you just used to cook your macaroni exists thanks to this force. As you know, atoms are made of electrons, protons and neutrons. Electrons have negative electric charge, protons positive, and neutrons, well, are neutral. Salt is made from chloride and sodium ions. The chloride anion has an extra electron and thus is negatively charged, hence attracting the positive sodium cation. As you can tell from its name, electromagnetism is not just about electrically charged particles, but also about magnets, like the Earth itself. Thanks to this, we avoid being burned by solar radiation. So, thanks electromagnetism. Let's now get serious. Let's go with nuclear forces. First, weak nuclear force. Have you seen Oppenheimer? Of course you have. Well, that nuclear bomb is based on fission, that is, splitting an atom in half. But let me tell you that the sun makes something much cooler. Instead of destroying, it creates. The energy released by the sun comes from fusion. This is, combining two hydrogen atoms to make one of helium. All this is due to beta decay, a type of radioactivity that is consequence of the weak nuclear force. On the other hand, strong nuclear force. As its name implies, it is the strongest of the four fundamental interactions. Think of it this way. We talked earlier about the protons in the nucleus of the atom. As you may know, like charges repel each other, and protons are positively charged, so how come can the nucleus exist if the powerful electromagnetic force is trying to tear it apart? That's thanks to, you got it, strong interaction, which is about 100 times stronger than electromagnetism, keeping the neutrons and protons in the nucleus together. In the next video, we will see the building blocks of reality and the particles that mediate all these interactions. So keep tuned.